Welcome to This Explainer. Look, if you're building networks or securing systems, you already know the deal. Cybersecurity is this invisible, never-ending battle. Today, we're diving into the absolutely vital first layer of security engineering, the firewall. I want you to think of it as the great, fortified city wall of the internet. We're going to trace exactly how it evolved and see why, especially now in the AI era, that wall has had to drastically adapt. All right, to really appreciate the castle wall, we first need to take a hard look at the wilderness outside. I want you to imagine something, well, honestly, it's pretty terrifying for any systems engineer. Imagine taking a naked, completely unprotected Linux server and plugging it straight into the raw, unfiltered internet. No barriers whatsoever, just a direct connection. So what do you think happens? Does it just sit there quietly, waiting for real users? Not a chance. Within mere minutes, that server is going to light up like a Christmas tree. Almost instantly, it gets hit by an absolute onslaught. We're talking SSH scans, bot probes, super aggressive port scans, brute force attempts, the whole shebang. Automated attack bots are just constantly, endlessly roaming the web. And why? Because the internet itself is literally a massive, ever-present attack surface. It never sleeps. This hostile, immediate reality is exactly why enterprise networks simply cannot survive without a border defense. The firewall isn't just a nice-to-have. It's a non-negotiable first line of defense.
So, how did we actually solve this in the early days? Let's step back in time to Section 1, Generation 1, the stateless gatekeeper.
These early firewalls, they were essentially incredibly rigid border guards checking passports based on a very strict set of rules, which we call access control lists, or ACLs. They operated on super basic logic. They only looked at the source IP, destination IP, the ports, and the protocol. So you might have a classic allow rule, letting anyone access a web server on TCP port 443, meaning HTTPS traffic is perfectly fine. But then you'd have a strict deny rule, blocking the external internet from ever touching SSH port 22. Pretty simple, right? But here was the fatal flaw. These early firewalls were stateless. They only evaluated single, isolated packets. They had absolutely zero idea if a packet was actually part of a legitimate ongoing conversation. They just blindly read the rulebook. And that, right there, forced a crucial evolutionary leap, the stateful firewall. Guys, this wasn't just a minor patch or update. It was a total paradigm shift. Instead of treating every single packet like some isolated event, a stateful firewall actually records the context. It monitors the TCP session, keeps track of the connection state, and follows that whole SYN/ASK handshake flow. Basically, the firewall finally gained a memory. Let's step through exactly how this memory works in practice, using what's called a session table. Step 1. An internal host initiates an HTTPS connection to a website out on the internet. Step 2 is where the magic happens. The firewall dynamically creates a temporary record in its session table. It's basically jotting down a note saying, hey, I saw this internal user ask for this specific external web page. Finally, step 3, when the website replies, the firewall checks its table. It sees that the return packet perfectly matches that legal established connection and lets it through. Just knowing which packets belong to legal connections, that was a massive security upgrade. It totally stops attackers from just spoofing return traffic.
But, the internet kept growing and attackers definitely got smarter. This brings us to Section 2, Generation 2 and 3, NAT and next-gen firewalls. First up, we have NAT, or Network Address Translation. You're probably already familiar with how this proxies your private internal subnets, translating them into a single public IP. By obfuscating your internal topology, basically hiding the layout of your network from the broader internet, NAT provides this incredibly powerful foundational layer of defense. Now, this brings us to a stark contrast and the next major leap in our story, the Next Generation Firewall, or NGFW. Traditional firewalls only checked the IP, port, and protocol. They were completely blind to the actual content inside the packet. If traffic was coming over port 443, a traditional firewall just shrugged and went, looks like HTTPS, let it in. But modern cyber attacks are way too complex for that. They actively hide inside those allowed ports. And NGFW brings application awareness. It checks the specific application, the user identity, the URL, and critically, the payload itself. It actually knows the difference between someone harmlessly watching YouTube on port 443, downloading a file from Dropbox, or an attacker secretly tunneling malicious SSH commands right through that exact same port.
Because of this deep inspection, we really need to clear up a massive point of confusion in cybersecurity, the difference between a firewall and an IPS. At its core, the focus of a firewall is traffic control. It asks, should this connection be allowed or denied? On the flip side, an intrusion prevention system, or IPS, asks a totally different question. It asks, does this allowed payload actually look like a cyber attack? An IPS is in there scanning for signatures of SQL injections, buffer overflows, malicious shellcode, you name it. Today, a next-gen firewall actually integrates both of these capabilities, along with URL filtering, antivirus, and sandboxing, into one massive unified security platform.
You'd think, at this point, the castle is basically impenetrable, right? Well, here comes the plot twist. Section 3. The climax. Blind spots and modern disguises. The harsh reality here is that a firewall is literally only as good as what it can actually see and understand. And modern attackers, they've learned to disguise themselves brilliantly to bypass that castle wall. They use heavily encrypted malicious traffic, completely blinding the firewall's inspection engines. They spin up HTTPS command and control servers to make their malware communication look exactly like everyday web browsing. They leverage zero-day exploits that have zero known signatures, so the IPS just waves them right through. And worst of all, they're now using AI-automated mutating payloads that actively change their shape to evade detection. Traditional firewalls just can't read these modern disguises. Because attackers are inevitably going to find a way inside, our architecture absolutely has to adapt. Section 4. The future. True enterprise architecture. So, how do we actually build this out? It's all about what we call defense in depth. Real enterprise security is a multi-layered architecture. Yes, you have your edge firewall, but you also have internal segmentation firewalls to stop an attacker from, say, pivoting from the HR department over to finance. You've got web application firewalls protecting your front-end apps. You deploy EDR to monitor the actual laptops and servers themselves, while a SIM system aggregates all that data in real time. And wrapping that entire package together is threat intelligence and a zero-trust architecture, where we just assume the network is already hostile and we constantly verify everything. The firewall is no longer the entire castle, folks. It's really just the outer moat. Which brings us to a final, kind of lingering thought for this explainer. Cybersecurity is fundamentally shifting from rule-based defense over to behavior-based defense. AI firewalls, behavioral analysis, extended detection and response, this is the new frontier. As this quote beautifully sums up, future defense is not just blocking, but understanding the behavior behind traffic. Attackers aren't just trying to smash the wall down anymore, they disguise, they infiltrate, and they mimic legitimate traffic. So I'll leave you with this. If the castle wall alone is no longer enough to keep the shadows out, how well do you actually know what's already moving inside your city? Thank you so much for joining me, and stay safe out there.